today we're talking about the Pythagorean Theorem. And the Pythagorean Theorem says, in a right triangle, the square, which is the little 2, of the length of the hypotenuse is the big guy, is equal to the sum, which is a plus, of the squares of the lengths of the legs. You get to be a leg in a right triangle if you are any one of the 2 shorter sides. So typically we draw it. So let's go ahead and put this on our paper. So draw your right triangle. A right triangle has a 90-degree angle in the corner. The little box in the corner means 90 degrees. The side across from the 90-degree angle is always going to be your hypotenuse. And we usually give that the letter little c. Then it doesn't matter who you call A and B. I usually go left one A, right one B. So I'll usually say A here and B here. So your hypotenuse is always C, and your A and your B are just either one of the legs. So if I square, in a right triangle, so we have a right triangle, the square of the length of the hypotenuse, so that is C squared, is equal to, so the length of the hypotenuse squared, that's C squared, is equal to the sum, and Ethan, what is sum again in math?
Addition.
Addition, so that's a plus. Is equal to the sum of the squares, that's the little 2 again, of the lengths of the legs. So that's A squared and B squared. So I find my leg length, I find my other leg length, square both of them first, then add them together, and then they're equal to my hypotenuse squared. That should be pretty, that shouldn't be new to you. If this is the first time you're seeing the Pythagorean theorem, then I'm sorry I have failed you up until now, but I'm pretty sure we've done it this school year already. All right, so the next guy that we're going to look at is a crazy little guy called the Pythagorean Triple. This, if you are in the Pythagorean Triple phase, it's pretty cool. Any 3 numbers, and here we use the word integers, that satisfy A squared plus B squared equals C squared. So any 3 numbers, A, B, and C, that when you square the A and B equal the square of C, that's a Pythagorean triple. So let's look at some common Pythagorean triples. Classic 3, 4, 5. And just so you can see, Piper, what's 3 squared? What's 3 times 3?
3 times 3 is
9. And Jenna, what's 4 squared? 16. And Brianna, what's 5 squared? And Aaron, is that true or false? Is 9 plus 16 equal to 25? Aaron is nodding his head, yes. So 3, 4, and 5 are a Pythagorean triple. So there's a variety of numbers. Any multiples of a Pythagorean triple will make another Pythagorean triple. So if you multiplied each of these by 2, 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So you see how these 6, 8, 10 are doubles of 3, 4, 5. And then Jose, what is 6 squared? 6 times 6.
36.
Mm-hmm. And then Rudy, what's 8 times 8?
4.
Oh, you don't need one. You can do this one, right, Anthony? 10 times 10?
100.
100.
Yay.
Josh, true or false? 36 plus 64 equals 100. True. It's a Pythagorean triple. So 6 squared plus 8 squared equals 10 squared. Another common Pythagorean triple is 5, 12, and 13. Max, what's 5 squared? 5 times 5? 25. So this harder one. Brayden, do you know 12 times 12? 144. And then Brandon, 13 times 13? It's crazy. I remember it at, what's 3 times 3?
9.
And it's 169. Because I work with teenagers. So that one is just sticks out of my head. And then, Freddie, you have your calculator?
Yeah.
What is 25 plus 144 on your calculator?
Okay. What did you say?
25 plus 144.
159.
169, so this is true. So do you guys believe me that these triples are for real Pythagorean triples?
Yes.
Okay, so let's write in 8, 15, 17. 7, 24, 25. 9, 40, 41.
Oh my God.
And 20, 21, 29. Mm-hmm. Okay, so there's there's only 2 ways you can encounter Pythagorean theorem. One way is if you don't have the hypotenuse. If you need to find C, or the hypotenuse. So remember, the hypotenuse is always the one that's across the street from the 90-degree angle. So here is A, here is B. It's equal to, when we square each one of them and add them together, it should be equal to C squared. So we've got 5 squared plus 12 squared equals C squared. So we're going to square the 5. And by the way, what do you think C should be?
169.
So it's going to be 25, 144, and 25 plus 144 is 169. So find, when you have a squared, to find the actual number, you just take the square root. If you do not know how to use the square root button on your calculator, we did geometric means last week. Make sure you guys ask, because we have been using that. So our hypotenuse is 13. Because the square root of 169 is 13. The only other way to encounter Pythagorean theorem is when we don't know one of the legs. So when we don't know the hypotenuse, we take each leg, we square it, add it together, take the square root. So here's the process. We square it, we add it, and then we take the square root. Or when we don't know the hypotenuse, we take our 2 numbers, we square each one, add them together, and then take the square root. For this guy, when we don't know a leg, where we have leg squared, which is x, plus 7 squared, it's going to equal our hypotenuse squared. Remember, our hypotenuse is always the one that's across from our 90-degree angle. So in this case, we square it. So we've got x squared plus 49, 14 squared. So I remember this because I work with teenagers, so I know 13 squared is 169. 14 squared is 196. And I just remember because I'm a little bit dyslexic, so my brain remembers it's always the flip of 13. The second step we do when we don't know one of our legs is we subtract. So step number 1 is the same for both processes. We square everything. Then we subtract. So I'm going to minus 49 from both sides. And I'm looking to see if this is one of our Pythagorean triples so that I can stop thinking, and it's not. 196 minus 49.
133.
It's 147. That is not a perfect square. So in this case, we're just going to throw that into our calculator. The last step is going to be square root. And it's not going to be an exact answer, so we put the wavy equal sign to show that we know it's not exactly what we're going to round to, but approximately 12.12. So the wavy equal sign means not exactly, but around 12.1, approximately. Okay, so we're going to use Pythagorean triple for this beautiful little trapezoid here. Because we haven't talked about area of a trapezoid, we are going to cut this little shape up into 2 easier shapes. So go ahead and draw a line from this top corner, perpendicular to our bottom. Perpendicular to our bottom. Everybody's got to draw this. You guys are going to be asked to do this on your test, so I want to make sure that this process makes sense right now. So if the distance from here to here is 10, the reason we know it's 10 is because it's written on the top. The reason we know that distance is 10 is it's written above. So if this distance from here to here is 10, this distance from here to here is 16. The reason we know it's 16 is because it's written on the bottom. Joe, what is this distance from here to here? 6. From here to here is 6. Okay, so we're going to find the 2 areas. We're going to find the area of the triangle. A is for area, and I draw a little right triangle shape. Area of a triangle is 1/2 base times the height. And we're going to add it to the area of our rectangle. Area of a rectangle is base times height. We did area of a rectangle on our chapter review, and we did it on our chapter test. So it's good that we're reviewing it now. If you see it on a chapter test, it's probably going to be on your final as well. Okay. So the area of this little triangle, it would be nice. Here's the base. The base is 6. Thank you, Joe, for telling us.
Yeah, Joe.
But we don't know the height. Is there a Pythagorean triple that has 6 and 10 in it? Is there a Pythagorean triple? Look at your list of Pythagorean triples. What's the missing number here? 8. So we can say h is equal to 8, and then we'll say our work will be Pythagorean trip. Pith trip. So we can say that this is 1/2 times 6 times 8. And then we have our little square here, our little rectangle. This is 10, and this guy is 8. Because it's 8 over on the left side, it's got to be 8 on the right side as well. So the base of our rectangle is 10. It was written on the top. We transferred it to the bottom. And our height is 8. Okay. So let's do the math. This will be fun.
Yeah.
Are you ready? 1/2 of 6. 3. 3 is young. 3 times 8. So 1/2 of 6 times 8 is 24. Easy peasy. Are you ready? Ellen, you ready? 8 times 10. 80. Isabella, 24 plus 80. It is 104 meters squared. All right, our last chapter test had a question about isosceles right triangles. So we're going to draw ourselves a proper isosceles right triangle. So let's go ahead and throw down our L shape. We want to make sure the height of our L and the bottom of our L are about the same because it's supposed to be the same. Isosceles means two sides are the same. So I want the top and the bottom of this triangle to be the same length. Once you have it about the same length, go ahead and put your hypotenuse in. And we're going to put in a little tick mark to the left and the right to show that the sides are the same.
No.
The hypotenuse is 18. And the question is, what is the length of the leg? So we're going to let the length of the leg be a letter X. If it's X on the bottom of the triangle, it's X on the left-hand side too. It's an isosceles triangle. Those two are the same. Two sides are the same. Now here's the Pythagorean theorem again for you. A squared plus b squared is equal to c squared. Pythagorean theorem from the previous slide. Devin, are you ready with your calculator? No. It's happening. I don't have a calculator. Okay. All right, so we're going to let this side here be A, this is B, and this is C. So instead of A, I'm going to put an X. Instead of B, I'm going to put an X. Instead of C, I'm going to put an 18. Here's where we need the calculator. 7, what is 18 times 18? 324. Okay. out there, you have your calculator ready? Okay. So here's a crazy question. We kind of did fuss with x squareds the last couple of chapters. It was in your chapter 6 test. And here is, if I have an x squared, and I have another x squared, I'm adding them together, how many x squareds do I have? What is 1 plus 1?
2.
2. Is that a lot?
No.
Then don't answer a lot, because it's exactly 2. So if I have 1x squared and I'm adding another x squared, I'm getting 2x squared. It's like saying I have one student and another student coming in at lunch. How many students are coming in at lunch? 2. Not a lot, but specifically 2.
A few. Ooh.
All right, so out there we're going to solve this equation for x. And to do that, we got to divide by 2. So can you, in your calculator, go 324 divided by 2?
162.
162. Okay, sorry, it's hard for me to hear all the way up here. So 162. And then to find out what x is, we have to do the opposite of squared. So we're going to square root. So x is equal to 162 is not a perfect square, but what's half? This is we're back to the beginning. So Piper, what's half of 16?
Half of 16?
Yeah.
So, 8.
Mm-hmm. And here's an easy one, Jenna. What's half of 2? What? So 162 is the same thing as 81 times 2. Brianna, 81 is a special perfect square. What is the square root of 81? It is 9. So we're going to go ahead and take that 9. He is going to get released from his square root prison. But unfortunately, 2 remains inside because it's not a perfect square. So the answer is x is equal to 9 times the square root of 2. Okay, so those of you guys who thought chapter 7 was over and we'd stop doing the square root shenanigans, sorry, Pythagorean Theorem is really the reason we need all those square roots in the first place. Okay, so we're going to see this in the opposite manner as we had before. We have our square here. So this, again, is our isosceles. Right triangles. Here's our, we have that the diagonal is equal to 5. We need to find the side lengths so that we can find the area. So we're going to walk through this same process again. So I'm just going to focus on same problem as example 4. We're going to square both of the sides. X squared plus x squared equals 5 squared. Okay, and then Aaron, if I have 1x squared and I'm adding another x squared, how many x squareds do I have? 2. We have 2x squared. So we're going to go ahead and make that our 2x squared. And Jose, 5 times 5.
25.
25. Rudy, how am I going to solve for x squared here? Divide by?
2.
By both sides by 2. And then Anthony, I don't see your calculator. Do you know what 25 divided by 2 is?
Ooh.
What is it, Jose?
12.5.
12.5. All right, Josh, do you have your calculator as well? Because what's the next step?
Just square. Oh,
Sorry, it was the same step up here. So what is this called? Square?
square root.
Square root, right. So we're going to take the square root of both sides, and 12.5 is not a perfect square. And it's a decimal, so we know it doesn't have any factors that are perfect squares either. So we need a calculator, put it in, and take the square root. So Josh, we'll wait a moment when you grab your calculator and so you can tell us what this is. All right, so square root of 12.5.
It says 3.5.
Are you rounding to the nearest 10? Or is there not a decimal? That's fine. Yeah. Easy. So, sadly enough, Max,
Uh-oh.
is it asking us to find the side length of this square?
No.
Oh, boo. So we have to do more work on this. So how do we find the area of a square? We did it twice on our chapter 7 test. So you don't remember?
No.
How do we find the area of a...
I didn't know.
How do we find the area of a rectangle? Base times height. So the area of a square is going to be base times height. So you're going to take 3.5 times 3.5. And here's a crazy thing. It's actually straight up 12.5 if we don't round it. So if I take and leave all the decimals, so what? What's the beauty of this part? So we took the square root of 12.5, and that's 3.535533999. If we times this by itself, which is the same as squaring it, we get 12.5. So the area of this square is exactly 12.5. But rounding it actually changes the value of the area. And Brayden, how do we find the perimeter of any shape? Okay. Perimeter. Area is everything in the middle. Perimeter is everything on the outside. So we're going to add all of our 3.5s together. How many of them are there?
2, 3,
It's a square. How many sides does a square have? 4.
4.
Square does have 4 sides. You can do 3.5 times 4, and that's how I'm going to roll it out on my calculator.
14.
So the perimeter is approximately equal to 14. I'm afraid that you guys are losing the fact that the area, if we round the side length, is 12.25. If we don't round the side length, it's 12.5. Did you guys catch that? Or is that part completely off? I'm moving. I'm doing the robot.
Do the Fortnite dance. All of
I have plenty of chairs right now. Or you can take a global approach to problem solving and move your body to a different location.
Aaron, was that necessary?
Yes.
Or you can expect other people to solve your problem.
That's not how I works.
Right? Not real life expectations. Okay.
Yeah.
All right, so converse.
Yes.
You guys, this will go really easy.
Still recording.
So the converse of the Pythagorean says, if you meet the requirements, a squared plus b squared equals c squared. If you meet those requirements, then you can say, yes, it's a right triangle. So my dears, when you see this on your test, they're going to say, is this a right triangle? You cannot just put yes or no. You have to show a squared plus b squared equals c squared. It's not a yes or no question, even though in your mind you're thinking, yeah. You have to show, if you just put yes or no, you're going to get it marked wrong. Automatically, without any work, you're going to get it marked wrong. You need the justification. So is 8 squared plus 7 squared equal to 113 squared? I'm going to pause and you guys can use your calculator and figure it out.
Back to.
All right. We're on math celebrating. All right.
I've already answered.
Everybody's already had one turn. So Brandon, what's 8 times 8? 64. And Freddie. 7 times 7. 7 times 7.
What's going on?
What is 7 times 7? 49. And Jenna, here's a crazy question. Square root of 113, when we square it, what is that? Yeah, it's 113. A square and a square root cancel each other out. Okay, Judy, no, it's Joe. Joe, 64 plus 49 is 113 equal to 113. So put a check mark next to it. I don't want to take the joke. Okay? Yeah. It's a yeah.
When do we get it right on the board?
All right, so we're going to test B the same way we tested A. So we're going to go 15 squared plus 36 squared and try to see if it's equal to 4 times the square root of 95 squared. All right, guys. All right, you guys decide. Make sure you have your calculators ready because it's coming to you. Ju Young, 15 squared. 325. Dylan, 36 squared. Great, crazy number. Parentheses, 4 root 95, close parentheses, square.
It's 380 then?
Okay. It's a whole number, right? We said 380. Let's just double check because that's a little bit difficult one. So we go 4 times the square root of 95 equals,
Yeah.
and then square. Hold on. Square root equals, and then square it. There. I got 1520.
Could you go over that one more time?
I got 1520. So you guys make sure you know how to use your calculator well enough. So if you go 4 times the square root of 95, in my calculator I have to put 95 and then square root. If you're using one of the blue TI calculators, you put 4 and then square root, second square, 95.
Okay.
Hit the equal sign. You should get 38.98 approximately. And then you square it. So hit the little squared button. You get 1520.
Whoa.
All right, thank you, Nick. And then Isabella, what is 225 plus 1,296? $1,521. And then Devin, go ahead and press where it says press on that green triangle. Oh, no action required, just a button push. Is 1521 equal to 1520? No. If you just put no, I'm going to mark this answer incorrect on your test. You have to show me that 1521 is not equal to 1520.
How do you want them to show you that?
Just like I did here.
That shows itself.
So they have to square each side, add it together, and it should equal the hypotenuse squared. Without those steps, the answer is automatically, Freddie, automatically incorrect. Without the steps. A yes or a no is not sufficient enough to get the right answer.
Look at this.
So there's 3 options when you have the length, the side lengths of a triangle. If your 2 sides if you add your 2 sides together after squaring them and they are smaller, so when you add the 2 sides together and they're smaller than your hypotenuse, that means you have a big hypotenuse. So show me your big hypotenuse again without hitting anybody. So that means you have a big hypotenuse. I'm sorry. Bring your hypotenuse closer together because a squared plus b squared is smaller. So that means your hypotenuse is smaller and you're an acute triangle. So you guys need to circle acute. And that some of you guys don't remember what acute means. It means that all the angles are smaller than 90 degrees. So if your a squared plus b squared is smaller than your c squared, then you're an acute triangle. If your a squared plus b squared is bigger,
Bigger than.
the square, no, I got it right, sorry. You guys get your eraser out? Because I wrote it in reverse order. So we do that. If your hypotenuse is less than, so Our alligator is eating the a squared plus b squared. Sorry, so it is the scenario. So if my a squared plus b squared is less than my c squared, so my c squared is the tiny guy, so he's less than, then we're acute. If a squared plus b squared is smaller than your c squared, so your c squared is big, then you have an acute triangle. So I think about it like this. So if my hypotenuse is big, I have an acute triangle. If my hypotenuse is smaller, if my hypotenuse is big, I have an obtuse triangle. If my hypotenuse is smaller, I have an acute triangle. And here's where my A students are going to distinguish themselves.
Hey.
What if they're equal? What if a squared plus b squared is equal to c squared? What kind of triangle do you have?
That's also right. Equilateral.
That's why those of you guys who said right are my A students.
Hey.
So if they are equal, if a squared plus b squared equals c squared, you have a right triangle. That's the Pythagorean theorem.
Wait,
You left it.
why would it not be equilateral?
They're not all equal. If when you square one side and square the other and add them together, if it's equal to the hypotenuse squared, then that's Pythagorean theorem. Okay, so our first value right here. So we're going to test each one of these items. The first thing we're going to do is we're going to put a C above the biggest number in each string. Because if you can't identify the C, then we're in big trouble here. There's no way we can tell. The C is always the hypotenuse. He is always the big one. So we're going to put a C above the biggest number in each of these string of numbers. Sometimes the string of numbers is not going to be equal. They're not going to be littlest to biggest. Like in C, the biggest number between 97, 72, and 65 is 97. He comes first. So we're going to do a little test. We're going to go 38 squared plus 77 squared and see how it compares to 86 squared. So let's do that together on our calculators. So 38 squared plus 77 squared equals 7373. We're going to compare that with 86 squared. It might not be equal, and that's okay. 86 squared is 7396. Let the alligator eat the bigger one. 7396 is bigger, so the hypotenuse is bigger than the sum of the two sides. So we are finding the one where it's bigger. That's the second one here. So we are obtuse. So we take the obtuse and we go check. We do the same thing here. We're going to test 10.5 squared plus 36.5 squared and see how it compares to 37.5 squared. 10.5 squared plus 36.5 squared equals 1442.5. You want to know how that compares to 37.5 squared. In this case, 37.5 squared is 1406.25. really distracting for me what you're doing right now. Waving your hands and talking. It's really distracting to me. It's hard to be a good teacher when you're being distracted. Alright, so 1,442 is bigger than 1,406. So when we have our a squared plus b squared that's bigger, in this scenario, we know we're a cube. Okay, last one. We have 72 squared plus 65 squared. We want to compare it to 97 squared. 97 squared is 9409. 72 squared plus 65 squared is 9409.
Right. And it's a right angle.
When they're equal, you are right track. Okay, last one. So we're making a foundation. And by the way, I've done this. I did this for my hot tub. Mr. Mitch and I went out to the backyard. We nailed in some form boards to make a foundation, but first you start with string.
Did it work? You put your homemade pool?
We put our hot tub on there. Our hot tub was 13 feet by 13 feet. Oh no. Our hot tub was 11 feet by 11 feet square. So we did a pad that was 13 feet by 13 feet.
Are you gonna build in a pool one day?
We did.
Like it's built in?
It's a doughboy pool with a deep end, so we dug out the end and it goes down.
So what
7
do
feet.
you mean by that?
That's exactly what she.
Okay, so we have
Look at her pictures.
30 feet by 30 feet by 72 feet by 72 feet. So we tie the string around each stake. And then we're going to see, and I did exactly the same problem to make sure that my concrete slab was square. You measure across the diagonal. Measure across the diagonal. Sometimes, so imagine a string. I'll help you guys. This is a foundation for like a, it's for like a garage.
Where's hot tub?
Okay. So, Julian, go ahead and grab this one too, Julian.
30 feet?
Okay, so Julian and I are making a rectangle. If I get my measurements wrong,
That's cool.
so if I get my measurements wrong, so say I go to the side a little bit,
I hate.
is this a rectangle?
No.
It's a what? Parallelogram. If they're all the same side, it would be a rhombus. So in order to make sure, and you guys, this is legit building stuff. In order to make sure that you're square, because when you get, the bigger you get, the harder it is to see if you're square or not. I can't use a t-square for 72 feet. So to tell if something's square or not, you measure the diagonal. So when it asks the first question, is this guaranteed rectangular? We say no. If it's off, it could be a parallelogram. And in fact, this picture kind of looks parallelogram-y. Like this. It's a little parallelogram. So we get a diagonal. It measures 78 feet. determine, using Pythagorean theorem, if we have a true rectangle. So we're going to test, is 72 squared plus 30 squared equal to 78 squared? So this is 6,084. And I'm hoping, so I'm going to put the equal sign there, but that's just a hopeful equal sign. So if I'm doing this project, I'm hoping it's going to equal 78 squared.
Yes. It does. And guess what?
So by the converse of the Pythagorean theorem,
What is that phrase?
it's a rectangle.